Welcome to the Destiny of Manufacturing podcast. I am your host, Dean Phillips. And of course, the Destiny of Manufacturing is powered by the Precision Metalforming Association. And I'm proud to be here today. I have with me the CEO from Dayton Rogers, Stephanie Lowry. Please welcome.
Hi. Thanks for having me, Dean.
It's great to have you here today. One of the things that we always do on this show is ask right away, what's your big takeaway for the next 5 years?
I think my biggest takeaway is going to be that companies have an opportunity right now. So this is their window to start preparing for 2030. I think 2030 is going to be a milestone year for this industry. And right now is your time to prepare and make sure you have all your ducks in a row.
Yeah. I think that's a great point. And technologically, how do you think this is going to progress? What certain areas of technology do you think are going to be the big, I know some people like the term of, are going to be things that will game changers, whatever your preferred topic is or preferred way of calling it. But what do you see those being?
I think that one of the buzzwords, that we're hearing everywhere now is AI. So that's going to be a huge one. But how do you incorporate that into your current business? There's a lot of different types of AI. It changes daily. And there's all these different automations that you can do with AI. So I think starting to go down that path, if your company hasn't explored this, because AI, when I say AI, I think a lot of people are thinking ChatGPT. That seems to be a big one that comes up. It seems like most companies, technology companies now have their own version of a ChatGPT. But how can we integrate that into machine learning? And I think that's the area that, at least here at Dayton Rogers, that's what we're focused on, is integrating that AI and that advanced automation into our current machines. A significant use of new robotics and using that AI to do things like preventative maintenance, real-time quality inspections, using visualization systems and things like that. I don't know if you want to get into that right now or not, but there's just all kinds of different things that AI is going to be able to assist us with in the very near future, if not right now.
Yeah, it is an exciting time. I will say that one of the things that often I always look at when I look at technology and where we are today is the availability of technology. It isn't just technology, it's the availability. Robots that used to cost millions of dollars, you can get that same technology in a smaller package for a lot less money in, say, the form of cobots and AI technologies. When you look at what is available today, what are the things that excite you about what's going to change and how your plant is already taking that on?
Yes. So I think, as you mentioned, just the affordability of it, before you would have to invest a significant amount of money to build a robotic cell, if you will. And now you can get a cobot for, under $5,000. It's extremely affordable, and that pays itself back within a couple of months, if you're a high volume stamper. So, or fabricator. So, I think that there's a lot of opportunity to automate and also just using the technology available to us today. Like, for example, so one of the things that we're working on here is training a machine learning model that, if there's a specific high frequency in a bearing and it senses that, and that's coupled with a rise in temperature, that's going to historically precede a machine failure. And then that alerts our maintenance team, hey, we need to shut this machine down for, before this date because it needs a PM, a preventative maintenance. Doing those little things to prevent a die crashing and then having to get pulled out of the machine and, go in for repair. Those little tiny things really add up throughout the year,
Mm-hmm.
Yeah.
100%. And I think hit it on the head. One of the areas that how we map this information, uh, because there's this old term of uh, that causation doesn't determine causation, that
Yeah.
just because we have these results doesn't automatic correlation doesn't automatically mean causation. And when you talked about that, about how do I see this and this happening, one of the most important aspects is I look at machining centers. So if I run too fast, I get vibration and I
Yeah.
get more heat. And the impact of that, when I'm mapping that as a problem, do I see that I have an actual problem, or do I see that maybe I have a programming change that's happened that may be
Yep.
potentially causing that? And
Yep.
that's one of those areas that I think you're right, we can take advantage of. And then those models learning from themselves, okay, this wasn't a failure, this isn't a problem, because we didn't have necessarily the heat result that you were talking about with the vibrate, with the uh and you know, when you start talking about machines, vibration, tracking heat, tracking tonnage, or any kind of pressure that's related to it, integrating those is really important. Do you see that as being how we're going to teach these models to get better?
Oh, absolutely. I think that the majority of the models have sort of their own learning already integrated into themselves, so they'll continue to get better, like you mentioned. But also, it's a way for shops to improve their own efficiencies. The So one of the things that happens here is when we do get one of those notifications, we will go back on the work router and make sure we make those adjustments. So the next time we pull that tool to set it up in a press, we already have all the documentation. And that's something
Mm.
historically that many manufacturers I've talked to, it's the tribal knowledge, right? Of not knowing exactly, what height we need to set this press at. Knowing that you have to shim up the back left corner of this die. I mean, it's just those little tiny things that that
Yes.
everybody. It just takes trial and error normally, and AI is able to capture that and then report it back to us to help us get better. AI is smarter than us already, so let's use that to our advantage.
Mhm. Yeah, and it's quicker. I mean, I
Yeah.
mean, those decisions are that fast.
Yes.
But when it's looking at the information you give it, it can make those decisions so much faster than a human can. Not that we can't make quick decisions, we can, but when we're asking for really complex problems to be solved very quickly, that's where things can really take off. Let's shift a little bit about that. And you talked a little bit about robots. When we look at how robots used to be, one of the other aspects that I see when I go into plants is that you used to have a full-time programmer slash technician to
Mhm.
make that work, to make program changes, everything else. The machines seem to be smarter and learning, having learn functions or teach functions built into them, so that I can move it through the range of motion I want it to travel in. And that also helps it to be safer, because I can make sure that the range of motion it moves in isn't closer to an operator, but further away. So it may take a further path. And teaching those things, how do you see that same element being taken in most plants?
I think that that is the future of most plants. I I don't necessarily see it eliminating jobs or positions, but I see that increasing efficiencies in plants. So, when you bring a machine in, and you still need somebody that's going to be able to service it, program it, tell it what jobs is needed into that machine, but that machine can work all night long.
Mhm.
If you put a machine in there, you went from one shift to three.
Absolutely. Yeah.
So, I think that most plants are going to eventually move at least in that direction of automation. And we will start to see, hopefully, the schools that we've worked with here at Dayton Rogers, the schools are already adopting that. They're doing a lot more programming. The schools are getting grants to get those types of cobots, different robots, and things like that. to teach people how to program them because they see that as the way it's going as well.
Yeah. Well, and that I think I was reading somewhere not too long ago. Brad Coven had been on a trip, and he was talking about machines building machines, and
Which how
I
funny
thought
is
that
that?
really interesting and a real interesting perspective that maybe that's what we do, is that in the future we have machines to build machines in our plants that fit our needs, uh, as opposed to just building parts. We're actually building the equipment. So do
Yeah.
you, I hope that's true. I would love to see that happening where we have more of that availability to us to build that future. What
Yeah.
other technologies are you guys using at Dayton Rogers?
So one of the things that we have been doing a deeper dive on, we have quite a few servo presses here,
Mhm.
and so using servo presses to increase our energy efficiency and not necessarily replacing the traditional mechanical presses, but sometimes outfitting them with additional technology to turn them into a hybrid of sorts. A servo press is really nice because you gain a lot of process control and you improve the quality, which is all stuff your customers want to see and hear. There's also a lot of energy initiatives that are happening in the manufacturing space right now, and the servo presses are able to produce a lot of energy savings. So there's a cost, savings associated with that. Um, for example, so one of the reasons that we would use or switch over from a traditional mechanical press to a servo press is it has a programmable ram motion. So
Hmm.
basically, what that means, I know you're probably familiar, but for the people listening, so when the press comes up and down on a traditional mechanical press, it's going to go one speed. It just goes up and down, just like this. With a servo press, you can actually get it to the very bottom right here where it's just about to kiss the part and go very, very slow and then come back up.
Hmm.
So you can program it for different speeds, and that is going to help with the quality control. If you have deep draws or anything like that, it helps with cracking. There's just a lot of different benefits to having a servo press. So
Oh yeah.
cuts down on the list of repairs for dies and scrap rates and things like that. So those are all good things, all things that manufacturers want.
Right. Yeah. Oh, there's no question about it that if your biggest asset is your presses in your plant, and that's the potentially a bottleneck when that press goes down, you better be doing everything you can to make sure you take care of that asset.
Mhm.
And I don't know that we've always done that. I've seen for years where we've really abused our presses. And I know that we're also have been very slow. I would say that our industry in the stamping side of things versus the fab side been
Yes,
very slow to adapt this technology because
100%.
yeah. Now on the fab side of business, you see press brakes, you see equipment that has used servos for a very long time. They have
Mhm.
either had servo hydraulic or servo electric press brakes that bend metal and do all of these things, and have been taking advantage of these, shortening the stroke, controlling the velocity, those
Yes.
kinds of systems. Why do you think it is that we have been slow to adapt, or these other industries have not only have gone through these changes, but they change every few years because the technology changes?
Yeah, I think that the press technology has been keeping up. I think that the manufacturers themselves are reluctant to replace the machines. Because when you go and you look
Right.
at a new servo press, I mean, all of the technology is there. The same things that you're seeing in press brakes and things like that. All of that's there. I mean, I'm laughing a little bit at this because we still have presses on our floors that are from the 60s. I mean, and they run great, tried and true. It's like that the car that
Hmm.
just won't quit. So It's
Yes.
the balance between, do I, keep this asset that's fully paid off and depreciated, or, do we go ahead and make the switch over to, keep up with technology and the time. So I think finding a balance, my prediction is that in the next 5 years, manufacturers are going to really start to switch over, because as they get one or two of them, they're going to see the efficiencies gained. They're going to see, the increase in quality parts. And, at that point, it's going to be a no-brainer. So we'll start to see a surplus of those older mechanical presses flood the market. So if anyone's in
Yeah.
the in the market for a used press, just hang out for a couple more years.
Yeah. No, I agree with that because we have, uh, I think what has happened is for a long time, people have exactly what you said. This press is already paid for. That's number one. Number two, I it isn't a capacity thing. It isn't necessarily, it is exactly what you said, which is an improvement of the process. An improvement, I can control the slide velocity as opposed to just saying, well, I need to get more parts. It isn't a question of adding capacity specifically. It's more about improving the quality of the parts,
Yeah.
but also controlling, yeah, I can control my stroke so that I get more parts at the same slide velocities without having to go all the way to the top of the stroke. And
Yep.
what other technologies do you see leading on the automation side, for instance?
And there are a lot of, so I recently just did a plant tour, and it was a very impressive plant tour. They had so many different sorting machines.
Mm.
And so what I mean by that is, it was a cell, and they would come off of the press. They would go through this conveyor belt of sorts, and right during that conveyor belt, it would sort the different parts into different areas, just based on, they had one part that started out as the blank, and then it made 3 or 4 different versions based on what the customer was ordering off of that blank part. And it would go into the funnel that it needed to go into to create all 3 parts at the same time. It was a progressive tool after that to form the rest of them, but it would do all 3 parts at the same time.
No,
So, I mean,
I,
I was like, wow, that's great.
I've seen also one of the things that is really interesting that I found was controlling the speed, varying the speed of multiple conveyor belts. So there's one that feeds another, that feeds another. Now you can accelerate it for packaging purposes and other things, quicken up the inspections and then move it slower or faster depending on the spacing you want for the parts so that it
Yeah.
makes it easier for the operator to handle. I'm really excited about some of the technologies that we're seeing being incorporated in manufacturing plants. And what would you say to somebody? Now, I do want to ask how you got involved in manufacturing, but as part of that, I would like to, as an extension of that, can you tell us what would you say to somebody getting into this? Why they should embrace this, especially if they're interested in technology?
Uh, what I think that manufacturing is always going to be around. You're always going to need it. And what I like about manufacturing today is that it's evolving always. So I'm somebody that likes change. And this industry has changed so much since I first started getting into it. And it's just going to continue to get better. All of the technology, all of the different, new AI incorporations that are coming in, it's just going to continue to change and evolve. And it's exciting to be a part of something like that. So
Sure.
if you're somebody that likes that, it's a good time to get in.
Yeah. What got you interested in manufacturing?
Well, it was I wasn't always. Like many people, I kind of fell into it, to be honest. So
Mhm.
I started with Dayton Rogers actually right out of high school. It was, my first, full-time job, just to get myself through college. And I started out in our reception area in our Minneapolis plant. So from there, I moved around to a bunch of different positions within our corporate and our Minneapolis office. And in 2013, we opened our South Carolina facility. And I came down here to help open it up and just kind of get everything up and running. It was supposed to be a temporary assignment, and you know how that goes. and
Oh yeah.
um, and after my couple months was up, I said, "Well, what do you need me to learn to stay here?" And they said, "Well, we really need somebody in manufacturing." And I said, "All right." So that's how I got into it. I spent, about 7 years doing different manufacturing operations. Eventually, ended up running the plant, the South Carolina division, and have just kind of kept moving and building from there. It's I didn't start out with a passion for it, but as I continued to learn, it just, I mean, I even switched my college major, um,
Hmm.
because it was like, wow, I really enjoy this. I like being able to put things together and look at a blueprint and figure out how we're going to make that,
Mm,
because there's more than one way to make something, so it's figuring out
yeah,
what's the best process, what's going to service the customer the best way, how can we make it affordable for them, and so all these little challenges, I like that.
that's terrific. If you were thinking back to when you got involved in this, if you were to look at what technologies we have today, could you have even thought at that time that we would be
No,
where we are now?
absolutely not. No, I mean, it's like, the equivalent of everyone in, when we hit 2000 thought there was gonna be flying vehicles. I mean, that's the equivalent of, what's happening in manufacturing. We're at that point where it's almost flying vehicles. I mean, we have, whole shops that are just, automated. I mean, robot run. There's a handful of people and the whole place is just making parts all the time.
Right. Yeah. Stephanie, thank you so much for your time today to be on the call and, of course, jumping on the Destiny of Manufacturing podcast. We really do appreciate it. Thank you so much for your involvement. Tell me, why are you involved with the PMA? What made you get interested and why you wanted to be part of this?
Yeah, so Dayton Rogers has been a PMA member for many, many years, even predating my start with the company. Um, I got involved when I came down to the South Carolina facility. They wanted to start up, the chapter, the southeastern chapter down here in South Carolina. So I joined the board there. But PMA has been a part of my working life since I started at Dayton Rogers. I think that uh, it's intrinsically valuable. There's so much that PMA offers to manufacturing members, but some of the things that I really value about it personally is just the connections that I've made with other manufacturers that are going through similar challenges. Because whether it's an indirect competitor or just somebody that is dealing with the same things that you are, you're able to get together, network with each other, bounce ideas off of each other. I just got done with email chain where someone was asking, how do you have your sales commission set up? And I mean, there was probably 30 responses with open ended, here's how ours looks, and that's really rare to find, I think, in the industry, to be able to be that open and that transparent, within the same network.
It is very much a close knit group
Yes.
of manufacturing. I think a lot of people think it's this huge amount of people, and our industry tends to be, manufacturers as a whole is a very small group, and as part of that, the stamping group is a small subsection of that, but it is
We're
very
small but
close.
mighty.
Yes, that's exactly the way I would put it too. Thank you for putting taking those words from my mouth. Thank you.
The
Yeah,
other the other
it's
thing I did want to really quickly just mention, and I think I've mentioned this before about PMA, but they have an advocacy side, that they are constantly going out to Washington and lobbying on behalf of manufacturers, and that I think is a huge benefit because there isn't anyone else doing that, right? So they are making changes, they're going out, they're getting results. Um, uh, so I can't say enough about PMA and what they're doing on the lobbying side of things as well, because right now are challenging times. There's a lot
yes.
going on in Washington. There's a lot going on with tariffs. I know everybody's worried about that, and they're helping communicate what we want to see as an industry.
Yeah, we just had a tool and die division meeting not very long ago here at the FabTech show, and one of the things is that we had our advocacy group talk about some of those things, which I think really opened up the eye of the tool and die division. Now, for those of you who don't know, as part of PMA, we have a lot of networking groups, and one of those is the tool and die division, and it's incredible how people will share information, ideas, best practices
Yes.
in order to make the industry better. And I
Yeah.
think that's what I love about being involved with PMA too.
Yeah. They're wonderful. I can't say enough.
Yeah. Well, thank you again, Stephanie. I really appreciate you being here. And we will see you, I guess, at the Fab Summit.
Yep. That sounds good. Thank you so much for having me. It was so good to catch up with you.
Great to see you. Thank you.